Now, today we will do the next chapter, that is the periodic classification of elements, right? And what we need to understand is what is the necessity of classification of elements and why should the elements be classified and what are the different bases of classification, all right? So first let us understand this thing, why the classification is much needed. You know, there are hundreds of elements. So far, whatever elements are known, there are more than 100 elements. And to study and remember each and every element's properties is very difficult. So we need to classify them. The earliest of varied classification, as you know, that elements are classified as metals, non-metals, and metalloids. But what has happened? No two metals will be having the same property. Properties are different. Non-metals are having different properties, and likewise the metalloids also. So different elements are having different properties. So to study and remember each and every element's properties and etc., it is rather difficult. So therefore, we need to classify the elements. Understood it? And one such, the classification is basically divided into two. First one is earlier classification and then the later one. And the earlier classifications include all the classifications are based on atomic weight. So what is earlier classification means? The first one, as I told you, the classification stands like this way: metals, non-metals, and metalloids. And leaving out that, the earlier method of classification is, the first one is they are classified as what we can say that. This one, dominus triad. Triad means out of three. What does it say? If three elements with similar properties, then the middle element's atomic mass is the mean of the other two. The dominus triad means out of three. So when we have three elements taken, which are having similar in their properties, and we arrange them in the ascending order of their atomic mass, then the middle element's atomic mass is the mean of the other two. For example, lithium, sodium, and potassium. We know that all these three elements are similar properties. Lithium's atomic mass is 9. This is potassium is this is lithium is 7. Potassium is 39. Sodium's atomic mass is 23. So 23 is equal to 7 plus 39 divided by 2. That is average. So one element's atomic mass is the mean of the other two. That is average of the other two, and that makes the dominus triad. Understood it? So if three elements with similar properties are taken, then the middle element's atomic mass is the mean of the other two. Average of other two. Clear? Now, there are few elements which obey this rule, but not practically all elements are obeying it. You can't say that every element will be coming under the law of triad. So this, in later course of time, this was cancelled. Understood it? And the next one is Newland's law of octave. Newland's law of octave. Octave means out of 8. Newland's law of octave, which says, if the elements are written in the ascending order of their atomic mass, then the properties are repeated. Properties are repeated on the 8th element. As in this case, a musical note. What does it say? If elements are arranged in the ascending order of atomic mass, then the repetition of properties take place on the 8th element. That means the first and 8th are having similarity in their properties. Now let's take the case of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. And if these elements are taken, let us start with the lithium. This is you consider as the first element. 1, 2, 3, 4, 5, 6, 7, 8. That means lithium and sodium are similar in the properties. You catch hold of any one element. Say for example, I'm taking this boron. So you come in from here 1, 2, 3, 4, 5, 6, 7, 8. That means these two are similar in their properties. This is what is Newland's law of octave. Octave, the meaning you can understand out of it. If elements are written in the ascending order of atomic mass, then the properties get repeated on the eighth element, as in this case a musical note. Musical note, you know that the first and the eighth note are the same. And this is what is the Newland's law of octave. And in this law is nowadays it is not used, or in fact it is discarded on account of one reason. Now, we know that later onwards inert gases were discovered. Now, over this, instead of it will become neon, isn't it? And when neon comes in between, then what has happened? The order is changed. That means the rule is not followed. Every eighth element, the properties are periodic, but if inert gases are included in this, the law is violated. Now, why was inert gas not included during that when this law was made? Because it was not discovered at that time. Understood it? Inert gases were there. You know that inert gas, since they don't react, it was very difficult to find the presence of inert gas. You know, we can understand what is a metal, making it to react. We can understand the properties of a non-metal by making it to react. But inert gases, they neither react. They don't make any type of chemical reaction. Then how do we identify it? So that is impossible. So later onwards, it was discovered and when these gases were included, this law is not. So that is it is discarded. And you know, all these several classifications they all were based on atomic mass. Because remember, long time back, when these atoms had this Dalton has said, the matter is made up of very small indivisible particles called atoms. And atoms of the same element looks like they are alike. Isn't it clear? So when the elements were discovered, these things were studied, they are very small, etc. The properties of Dalton's atomic theory are studied in class 9 says. So what they knew only about the atomic mass. The electrons, protons, etc. were discovered much later. So what the scientists knew, whether the atom is heavier or lighter, they knew only about the atomic mass. Understood it? And that's the reason why I say that all the earlier classifications were based on atomic mass. All the early classifications were based on atomic mass, because atomic mass was only criteria which was known, nothing else. Understood it? So the law of octave says if elements are arranged in the ascending order of atomic mass, then the repetition of the properties are going to take place on the eighth element. First and eighth are similar. Understood it? The first one what we had studied was this one, Doberian's triad. Triad means out of 3. If you have 3 elements with the similar properties are arranged, then the middle element's atomic mass is the average of other 2. These 2 were true for few elements. But later onwards, when more elements were discovered and all these things were discarded. Understood it? And the next one is, that is the most important. This is the basis of modern classification. The main one is Mendeleev's classification. Mendeleev's classification. The first 2, what I told you, is Doberian's triad or Newland's law of octave. Simply they said a law is made. They said, okay, this is, if you arrange the elements in this way, this will take place. But Mendeleev's classification was the only systematic classification in which he formulated a law. Understood it? Others said, what did they say? You arrange the elements in the ascending order of atomic mass, then there will be properties repeated on the 8th element. That is it finally. You arrange it and repetition properties take place on the 8th element. The other fellow, Doberian had said, if 3 elements are arranged, then the middle element's mass is the average of other 2. There was no basis of any type of classification. In Mendeleev's classification, firstly he formulated a law, which is known as Mendeleev's periodic law. Mendeleev's periodic law. Note down. The periodic law says, the Mendeleev's periodic law states that the physical and chemical properties of elements, Mendeleev's periodic law states that the physical and chemical properties of elements are periodic functions of their atomic mass. The physical and chemical properties of elements are periodic functions of their atomic mass. Understood it? So that means, and what is the meaning of periodic functions? Physical and chemical properties of elements are periodic functions of their atomic mass. Periodic means something which is a period. You know that in classes we have different periods. One period is over, one teacher goes, the next period comes. After a particular time, something is repeated. That is what is known as periodic. And what it says, the periodic functions of their atomic mass. Atomic mass means, what does it say? When the atomic mass of elements are increased, the properties will gradually change up to a certain level, up to the maximum, and then again the next process is started. That is the meaning of periodic. You know, period which is repeated after regular intervals of time. Like we have classes, periods. After particular period, particular time, the bell rings, the next teacher comes. That is what is a period. Similarly, in periodic classification, the properties are repeated after regular intervals. Regular intervals means the properties are gradually getting changed. I'll take one example, like what I have written earlier. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. This is what I read because remember those days what they were doing is only the atomic mass. So the elements were arranged in the ascending order of atomic mass. Elements were arranged in the ascending order of atomic mass. Lithium, so lithium is a metal, beryllium is less metallic, boron is a non-metal, boron is a metalloid, carbon is a non-metal, nitrogen non-metal. Then what has happened? In this situation, as the atomic mass of the elements are getting increased, what is changing? The properties are changing. This property, the metallic property slightly getting decreased and it goes on up to the non-metal maximum. Then the next one is taken: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So what takes place in this? As the atomic mass of the elements are getting increased, the metal, it becomes less metal, metalloid, non-metal, 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 and non-metal. So what has happened? In this particular system, the properties are changed. How does it change? The non-metallic character is slightly getting increased. From metal, it is less metallic, non-metalloid, non-metal. So what has happened? The properties are gradually getting changed according to the increase in atomic mass. The atomic mass of the elements are getting increased, therefore, from the metal it is changing to non-metal. So up to a particular level. Then what has happened? Then again begin. Sodium, its atomic number, the atomic mass is 23, magnesium is 24, aluminum is 27, silicon is 28, phosphorus is 31, sulfur is 32, this is 35.5 and this is 38. So as the atomic mass of the elements are getting increased, what takes place? The metallic character of the element is getting increased and non-metallic character gets increased up to a level. So you can understand sodium is a metal, magnesium metal, aluminum metal, silicon is a metalloid, phosphorus is non-metal, sulfur, chlorine, etc. all are non-metal. The most non-metallic one is chlorine. So what takes place? In this particular one, the properties are gradually getting changed, and the change in properties depending on periodic function. That means periodic means which is being repeated after regular intervals. Understood it? So lithium to fluorine or neon goes on, and then sodium to chlorine goes on. Understood it? So this gradual change in the properties according to the atomic mass is known as periodic functions. Understood it clearly? So this is Mendeleev's periodic law. What is Mendeleev's periodic law says? The physical and chemical properties of elements are periodic functions of the atomic mass. You must understand the meaning of periodic function. Periodic function means something is repeated after periods, means something is which is repeated, and the repetition takes place according to the increase in mass. Understood it? So as the atomic mass of the element is getting increased and increased, the properties are getting changed. And that will go on up to a particular level, and then again it begins. What has happened? From a metal, it is going on up to the non-metal, and then again from a metal, it goes on up to the non-metal, and then again up to the from metal, it goes on to the non-metal. So that change in properties depending on increase in atomic mass. And this is what is the meaning of periodic function. So the physical and chemical properties of elements are periodic functions of their atomic mass. Remember, all the earlier classifications where everything was based on atomic mass, because the atomic numbers, the number of electrons and protons, etc., came into existence much later. Prior to that, we were knowing only one thing. The matter is made up of very small indivisible particles called atoms. And it was told atoms are heavy or light, nothing else. So properties or the classifications were based only on the atomic mass. Understood it clearly? So heavier elements or lighter, only that much. So this is about Mendeley's classification. Most important one is Mendeley's. You may get a question. Give a brief account of earlier classification, maybe 3 or 5 more questions. You need to explain about 3. Doberin's triad, then Newland's law of octave, and Mendeley's law. Another question is, what was the basis of earlier classification? Earlier classification was based on atomic mass. Understood it clearly? Now, how this Mendeley's periodic classification or Mendeley's periodic table came into existence? Those days, 64 or 65 elements were known. And what Mendeleev did, he studied each and every element's properties. Every properties was studied of each element with their atomic mass and etc. And he made a card for each element. Understood it? And out of that, like 64 elements were known, so he made 64 cards. And these cards were arranged in the ascending order of atomic mass. 2 things he observed. One, the arrangement should be in the ascending order of atomic mass. And the second one, the elements with the similar properties must fall in the same vertical column. Understood it clearly? When suppose like if you have been asked to write 1 to 20, either you will be writing 1 to 10, then 11 to 20, isn't it? That is a systematic arrangement. You won't be writing in a jumbled way like in a house heap. You won't be doing that. So the elements were arranged in the increasing order of atomic mass, left to right. And when these arrangements were made, one thing he made it sure that elements with the similar properties must fall in the same vertical column. So in this method, the horizontal and the vertical table came into existence. Have you understood it? The arrangement of elements were done from left to right in the ascending order of atomic mass. First point. And the second one, elements with the similar properties must fall in the same vertical column. So he got 2 columns. One is a horizontal column, and likewise the vertical columns are obtained. Understood it? So the horizontal columns, he called it as periods. And the vertical columns, he called it as groups. And remember, the other classification, they just said, okay, you follow this one, the properties will be there, or the elements are there, or whatever you do it. But this classification was entirely based on the systematic. He formulated a law. What is a law? The properties are periodic functions of their atomic mass. Then based on the law, he arranged elements. In how? Elements were arranged left to right in the increasing order of atomic mass. And top to down elements with a similar property. So 2 columns came into existence. The horizontal columns called as periods and the vertical columns known as groups. And in this method, Mendeley's periodic table came into existence. Don't just think that he made the table well in advance and started filling the element. It is not so. Understood it? Of the known elements, he made the cards. And the cards were arranged in the ascending order from left to right. And in such a way that elements with the similar properties were falling down in the same vertical column. And thereby, 2 things came into existence, the horizontal columns and the vertical columns. So he called the horizontal columns as periods, that is left to right columns as periods, and top to bottom columns as groups. So Mendeley's periodic table had periods as well as groups. Understood it clearly? And while these elements were arranged in this increasing or decreasing order of their atomic, there were a lot of abnormalities were there. And that became the advantages of Mendeley's periodic table as well as the disadvantage of Mendeley's periodic table. Understood it? Now, let's understand what is the disadvantage. He said the elements are to be arranged in the ascending order of atomic mass. Right? And when they are to be arranged in the ascending order of atomic mass, then what one must know? Isotopes. What are isotopes? Atoms of the same element having different atomic mass. Like we know the 3 isotopes of hydrogen: protium, deuterium and tritium. Protium, deuterium and tritium, 3 isotopes. Protium, that is ordinary hydrogen, has got atomic mass 1, deuterium 2, tritium 3. And you say the elements are to be arranged in the ascending order of atomic mass. That means the first element must be protium with atomic mass 1. And the second must be deuterium, atomic mass 2. And the third must be tritium. So what he did, for all these three isotopes of hydrogen, he gave only one position in this periodic table, one hydrogen. So what were the other two? He left. So that became the bromide. Understood it? Clear? There was no position of isotopes in the periodic table, right on? Isotopes are atoms of the same element. Isotopes are atoms of the same element having different atomic mass. Atoms of the same element having different atomic mass. And if elements are arranged in the ascending order of atomic mass, then the table must have position for isotopes, which he did not give. That became one of the drawbacks. Understood it? The next one. You know that sodium is a metal which is highly reactive. We have studied in the metals non-metals reaction. If sodium is left in air, it catches fire. And copper is one of the least reactive metal. So what has happened? Sodium, highly reactive, and copper, least reactive. Isn't it? These both are placed in the same group. That means, second, dissimilar elements are placed in the same group. Dissimilar elements are placed in the same group. Dissimilar elements are placed in the same group. What is the rule? Elements in the same vertical column must have similar properties. Okay, sodium is a metal, copper is also a metal, but copper is least reactive, sodium is highly reactive, or in fact gold. How can you place all these three metals in the same group? Not possible. So, but he placed them in the same group. So, dissimilar elements are placed in the same group. Understood? The next one. What did he say that? The elements are to be arranged in the ascending order of atomic mass. And when the ascending order of atomic mass is taken, for example, potassium has atomic number. If you see this one, the next one is potassium. Potassium's atomic mass is 39, whereas argon's atomic mass is 38. You say that the elements are to be arranged in the ascending order of atomic mass. And if you say that the rule must be followed everywhere, but here the rule is violated. Have you understood it? Potassium has atomic mass 39, argon has atomic mass 38. So this one, potassium, calcium is 14. This is argon, it is not 38, it is 40. Argon is 40 and potassium is 39. So what should it happen? When you are arranging these elements in the ascending order of atomic mass, first it should have potassium and then it should be argon. But this order is not followed. The correct order, that means the correct ascending atomic mass order is not maintained everywhere. You are formulating a rule and you yourself are violating the rule. You yourself are violating the rule. You said if the elements are to be arranged in the ascending order of atomic mass, that means every element with different atomic mass must find a place in the table. Or instead of that, you gave only one element, one position. And you say that elements are to be arranged in the ascending order of atomic mass, and if that is not followed, that is also became the drawback. And you say that elements with the similar properties must fall down in the same vertical column, which did not take place. So these all became the drawback of Mendeleev's periodic table. Understood it clearly? And if it has drawback, it must have certain advantage also. Important advantages of Mendeleev's periodic table. First one. You know, while this table was made, what did I tell you? He made number of cards, and these cards were arranged in the left to right position, ascending order of atomic mass, and vertical column elements of the similar properties. Understood it? So while these elements were arranged, in certain cases, he could not find element to fit into that place. He did not get element to be fit into that place. So what he did? He left that as a blank. So what is the first? The blank spaces left in the periodic table. The blank spaces left in the periodic table predicted the discovery of new element. The blank spaces left. No, you know, by knowingly he did not leave any blank space. It came by itself. Suppose like the tables were arranged left to right and ascending order and vertical column, he did not find the position. Therefore, what has happened? He left that as a blank. So blank spaces left in the periodic table predicted the discovery of new elements. Means this table was presented to the scientific community. Okay, I read this classification, you check it out. And when something is presented, everybody will do the postmortem of that. They did that. Understood it? And then if something is given, first thing they will not ask why the columns are filled. The question came into existence, why these columns are empty. Understood? They started questioning. You have filled all these elements. Why did not fill the elements over this place? Why you leave it as a blank? So that became, the scientists thought of why this column is empty. Something has to come. So that became predicted the discovery of new elements. And one could predict even the properties. Because what we have studied, vertical columns, elements with the similar properties. And if one element is blank, column is blank, we can understand, okay, what is the element on top of it? This. What is the property of this? Okay, this one. So this element will have somewhat like this property. So blank space is predicted the discovery of new elements. Understood? And one more advantage is there, see all these manipulations he made only to fit that elements into the table. Wherever he could find element, he could not find, he left that as blank. In some cases, what he did, to adjust the position of the element in the table, he said, these elements' atomic mass is being wrong. These elements' atomic mass is being wrong, he said. So what has happened? So he said, okay, the atomic mass of this element would not be this, it would be like this. So he changed the atomic mass of few elements to adjust the properties. Understood it? And later, after a number of years, the scientists proved that what mentally changes what he had made, it was the right one. The correction of few elements atomic mass he did was the correct one. So these were some of the advantages and some of the disadvantages. There is one more disadvantage, position of hydrogen. As I told you earlier, hydrogen is the only non-metal in physical in character and chemically it is a metal. Is it clear? So where should we place hydrogen in the periodic table? Whether it should be placed along with the metal or it should be placed along with the non-metals. So that is still a controversial question and that is a doubtful thing. And that's all for today.